Hey guys, it's Miss Johnson and I'm here to bring you our first notes video for Unit 3. We're moving into a unit that is all about polynomials. So today we're just going to talk about the different parts of a polynomial and how we identify those parts and what their definitions are. So that's our learning target for today. So there's going to be a lot of writing today because you're writing out a bunch of definitions, but maybe not as much math as we've done in Unit 2 for sure. So let's take a look at the first definition. Our first definition is a term. Terms are numbers, variables, or the product of a number and or variables. Terms are separated by addition and subtraction. Okay, so that's an important thing to think about. An example of a term would be something like 3x squared or 7ab or I don't know, 6y to the third. Okay, those are just a few examples. Notice that in 3x squared, there's no addition or subtraction. That's just one term. 7ab, no addition or subtraction, that's just one term. Even though there's three parts to that term, it's all one term. It's just one term. Okay. Let's talk about powers for a second. So in powers, we have two things. We have a base and we have an exponent. So the base of a power is the number in the power that's being multiplied. And the exponent of a power is the number in the power that tells you how many times you multiply the base. So if I look at an example, and you can use this example for both base and exponent, 2 to the third, the big number on the bottom is the base, and the little number on top is the exponent. This whole thing together, this isn't a term in your list, but this whole thing together is what we call a power. Okay, so that might be something that you can write down. But anyways, the big number is the base, the little number is the exponent. And what that tells you is that the base needs to be multiplied 3 times. Base times itself, 1, 2, 3 times. Let's talk about a coefficient. Now, you've heard me use this word a lot, but a coefficient is the numeric factor of a term that has a variable. The numeric factor of a term that has a variable. So basically, it's the number in front of the variable. If I look at an example here, let's say I have something like 7x. 7 is my coefficient. If I look at something like 6xy squared, 6 is my coefficient. So it's just the number. A lot of times when people write the coefficient, they want to write the variable behind it. X isn't a coefficient, X is a variable. So 7 is the coefficient out front, 6 is the coefficient out front there. Degree, this is probably a new one to you. A degree of a term is the exponent on the variable of the term. So for example, if I have something like I go back to 6x squared, let's say, the degree is 2. So we'll say that this is a degree 2 polynomial. If I have 3x to the 4th, my degree is 4. This is a degree 4 term. Okay. Like terms, this is something that is not new. We have seen and talked about like terms for a long, long time now. Like terms are terms that have the same variable raised to the same powers. And then one thing to note is that all constants are like terms. So like terms have the same variables raised to the same powers. So for example, if I had 7x and 3x, those are like terms. The variables are raised to the same power. If I have 6y and 7y, if I have something like 3x and 4x squared, those are not like terms. Even though they both have x's, this one is x to the first and that one is x squared. Those are not. But if I had 3x squared and 4x squared, those are like terms. So now let's talk about constants. Constant's an easy one. You've heard this a lot before as well. A constant is just a term that has only a number. Constants have no variable part. So for example, any number that you want. 7, 3, 2,000, 600, 728. Any number that you can think of is just a constant, as long as it has no variable listed with it. A polynomial. Now, you've probably heard the word polynomial before, but maybe not really done a whole lot with it in the past. A polynomial is a set of terms separated by addition and subtraction. So for example, if I had something like 2x to the third plus 3x squared minus 6x minus 4, that is a polynomial. If you think about the prefix of the word poly, poly means many. So you'll hear things like monomial. Mono means one. Binomial. Bi means two. Trinomial. Tri means three. So these are just kind of three examples of things we talk about with terms. A monomial is one term. A binomial is two terms. A trinomial is three terms. So a polynomial in general is just something with many terms. Okay. Then, if I talk more about polynomials, the degree of the polynomial is the largest exponent. Remember when we talked about degree of a term, that was the exponent of the term. But the degree of the whole polynomial is the largest exponent of all of the terms. So if I go back to the example that I just used, 2x to the third plus 3x squared minus, what was it? 6x minus 4. My degree here is the largest exponent, which is 3. This is a degree 3 polynomial. Okay. So that is something that we need to consider. So even though 3 is the degree of this term, 2 is the degree of that term, 1 is the degree of this term, and 0 is technically the degree of this term, if I think about the degree of the whole polynomial altogether, it's the largest power, which in this case is 3. So standard form of a polynomial. A polynomial is in standard form when the following things exist. All like terms have to be combined, and terms are written in decreasing order with the largest exponent first. So kind of like how I have this one written up here. I started with the power of 3, then went to the power of 2, then went to the power of 1, then went to the power of 0. And you can use that same example down here. So standard form is decreasing the powers. Start with the biggest, work your way down to the smallest. And then the last term that we're going to talk about is the leading coefficient. The leading coefficient is the coefficient of the first term as long as the polynomial is in standard form. Or in other words, it's the coefficient of the term with the largest degree. With the largest degree. Okay, so it's the first term as long as you have it written in standard form. So if I go back to that same example that I've been using, 2x to the third plus 3x squared minus 6x minus 4, my leading coefficient is 2. Okay, so let's flip it over on the back and just kind of put these into practice a little bit here. Number 1, I have 4x to the third plus 8 minus 3x plus 8x squared. Holy cow, a whole lot of terms. Minus 12 plus 5x plus 3x to the third minus 5x squared. Goodness gracious. So first thing I'm going to do is write this in standard form. Now here's how I like to write things in standard form. I look through all of the terms that I have, and I start by finding the largest power. The largest power that I see is 3. So I'm going to take my like terms that have a power of 3, and I'm going to put them together. 4 plus 3 gives me 7, so that's 7x to the third. Then I go to the next power down. The next power down would be 2. So I have a power of 2 here, and I have a power of 2 here. I'm done with the 3's, and by the way, if it helps you, you can cross them out as you go. So I have 8x squared minus, don't ignore that negative that's in front, 8x squared minus 5x squared is positive 3x squared. And also notice, by the way, when I combine my like terms, my power doesn't change. The coefficient out front changes, but the power doesn't. So those are gone. I'm done with those. Then if I look at negative 3x and 5x, those are like terms because they have a power of 1. That would be my next thing. So negative 3x and 5x, negative 3 plus 5 is 2. So positive 2x. Done with those. And then the constants, 8 and negative 12. 8 minus 12 is negative 4. So negative 4. I always check to make sure that I've taken care of all of the terms, and I have. I'm in standard form. There we go. So how many terms are there once it's in standard form? 1, 2, 3, 4. There are 4 terms. What's the degree of the fourth term? If I look at the fourth term, 1, 2, 3, 4, this is 4x to the 0. So my degree is 0. Now, we don't need to write x to the 0 because it doesn't carry any weight. It doesn't have any value. So typically you won't see it there, but recognize that that means it is a degree of 0. List all the coefficients. The coefficients are the number parts out front of the variable terms. So if I just make a list of those, it would be 7, 3, and 2. And then listing the constant, my constant is negative 4, and that's that one with no variable. Let's take a look at number 2. In number 2, I have all of those terms grouped together, and now, again, I'm going to go back and write it in standard form. So I'm going to start with the largest power. I notice that the largest power is the power of 3. I also notice that I have it in 2 spots. So I'm going to take those, and I'm going to put them together. Add the coefficients. 3 plus 2 gives me 5. So 5x to the third. Power didn't change, just the coefficients get added together. Then I would look for a squared term. So here I have 2x squared and 5x squared. 2 plus 5 gives me 7. So plus 7x squared. Then I have a negative 3x. So I subtract 3x. There's no like terms with the x. These are both constants. So the negative 3x is by itself. I'll just keep it like that. And then the last two are constants that can go together. Negative 12 and negative 6 is negative 18. I've taken care of all the terms. It's in standard form. My powers go 3, 2, 1, 0. So I know I'm good there. How many terms are there? Again, I have 4 terms. What's the degree of the fourth term? Again, I'm looking at an x to the 0. So my degree there is just 0. Notice that when I list the degree, I don't actually list the variable. I just list the exponent. List all the coefficients. This is another place where we don't list the variable. The coefficient is just the number part. So my coefficients are 5, 7, and negative 3. And I'm just making a list there. I can separate them with commas. And then what's the constant? The constant is negative 18. All right, last 2 questions here. I'm going to start by writing this whole big guy in standard form. I notice now that my largest power is the power of 5. So I'm going to start with that one. It doesn't have any like terms with it, so I'm just going to list it as it is. So 5x to the 5th. Then I would go to the power of 4 next, but I don't have any powers of 4, so I can really skip over that one. Then I would go to the power of 3, and I have 3 minus 2, which is just 1, or just x to the third. You don't need to write the 1 in front, but if you want to, if it helps you, go ahead. So those are gone. Then I would go to the power of 2, but again, I don't have any powers of 2, so I can skip over that. So then I go to the power of 1. This is a negative 2, that's a negative 4. So I have negative 6x to the first, but I don't need to write the power of 1. And then I would go to my constants. 4 and 5 gives me 9. So there's my standard form polynomial. Now again, we skipped over the power of 4 because we didn't have any terms, and we skipped over the power of 2 because we didn't have any terms. You don't need to write those powers in. This is your standard form here. The degree of the whole polynomial is that largest exponent. So the degree here is 5. And the leading coefficient is the coefficient in front, which is also, coincidentally, a 5. And the last one, 4x to the third minus 2x to the fifth minus x plus 4x minus 2 plus 5x to the third minus 4x. Holy cow, lots of terms. I start with the largest power. So I have 3, 5, 1, 1, constant, 3, 1. My largest power is 5. So I'm going to start with that. It's by itself. There's no like terms, so minus 2x to the fifth stays out front. That's gone. I have no powers of 4 again, so then I make a power of 3. So this goes together and that goes together. That's plus 9x to the third. And I have no powers of 2. I have a power of 1. So negative 1, negative 4 is negative 5x. This is a negative 1, so negative 1, negative 4. Oh my goodness, I almost forgot that I have a 4x here. Wow, back up. So get rid of this because that was wrong. Sorry. I have a 4x here as well. So I have a negative x, a 4x, and a negative 4x. Well, 4x minus 4x goes away. So this is actually just negative 1x, or just negative x if you want to write it with just the 1. And then my constant's negative 2. Gosh, I almost missed that. So degree of the polynomial, largest exponent, that's a 5. Leading coefficient, coefficient in front, that's a negative 2. Notice, by the way, that neither of those have the variable with them. It's just the number part. All right, so that's going to take us to the end of our notes video. Let's make sure we use our work time here and get our practice sheet done. Don't forget to check off your notes with Ms. Johnson. Thanks for listening, and I will see y'all later.